All right, I think we're live. Yay, we're trying a new streaming setup. Welcome to Azure Community Live for using OBS Ninja. So I'm here with Jens, and just before we get into today's topic, welcome again. So again, sorry about the couple of minutes late, but this is the Azure Community Live, an online community, and we are all about Azure, obviously, hence the name, for the community, and we are driven by the community. So the three hosts, I am one of them. There's also, I am in Australia, I'm Lars. And there's also Geert, or Geert, I believe it's pronounced, in the Netherlands for the European time zones, which we're also doing today, but I'm sort of cross-pollinating both continents. And then we got Esteban in the US doing those time zones. So we are kind of global community. And it's kind of interesting because we've all been working from home now for more than a year almost, a lot of us. And we started this project, this online community, about 14 months ago. And we had no idea what was in store for us with everybody working from home. So here we are. We'd like to think that we pioneered this format, but of course we didn't. But yeah, this is Azure Community Live. If you are interested in presenting, just like Jens is going to do today, give us a ring. No, don't give us a ring. Give us a message on Twitter or YouTube or email or website or wherever you can find us, and we will get you on the show. But we've made this mainly for people that can't get to meetups in general. Now, that is all of us at the moment, but that's going to change again, I'd imagine. But like, I live in the middle of nowhere. So this connection might not be the best because I am on a satellite connection and I can't wait for Starlink to solve all my problems. Right. But okay, enough about all the blah, blah. I am here with Jens Vestergaard, a fellow Dane. Jens is known as the BI dude, I believe. So business intelligence, if you're not familiar with the abbreviation. And I just have Jens's bio here in front of me, and it looks impressive, and I don't understand any of it. So I'm not a data person as such. I use data obviously in development, but I'm very keen to hear what Jens has in particular to say about KQL. So welcome to the show, Jens, and thanks for joining us.
Yeah, thank you for having me. I still have this echo. Do you have a speaker on, maybe, perhaps?
No, I can. I hear you just once. I hear you just fine. I am not sure about the live stream. Let me check for that, just in case there are people that are now hearing you twice. Let's have a look. I'm just going to check it. I think we're all right. It might just be that you have tabs open. So, no, I think you're fine. I think you're fine. So you might have two tabs open that gives you audio in both, is what I'm suspecting. So you might need to mute one of them. Yeah, but I can hear you just fine, but it is annoying hearing yourself again. Oh, now I've lost you. Now I can't hear you at all. The internet. This is like this is a proper video call though.
Yeah.
There is supposed to be a certain period of time where you go, can you hear me? No, I can't hear you. Can you, are you on mute? It's perfectly normal.
So let me just.
But I can hear you now.
Am I going through now?
Yes, you are.
Okay, perfect.
Yep, you are loud and clear now.
It was not. It was the speaker I had to mute on the other tab, not the mic. So there you go.
Aha. Gotcha.
Okay.
All right. Well, very good.
All right.
So what have we got? What do you got in store for us today?
Well, an introduction to KQL and Azure Monitor as a service. We use it somewhat extensively to monitor our application telemetry, as well as application loggings. We seek to find out when certain events was going on in our application. And also metrics on some of the services that we use in Azure. And obviously this helps us do both pretty well. And to have a more extensive deep dive into it, you need to kind of dig into KQL to manipulate data like you want it to be presented and so on. So that's been a small journey for us. We are data people. We know SQL and stuff like that up front. So the transition to KQL was pretty straightforward. If you're not coming from that area, you might have a little struggle getting there. But they do help us out a lot with examples, and also there's a community site on GitHub where you can get a kickstart from a lot of different queries on different services. I'll just share the link in the video. Other than that, we will get into seeing how you can interact with it through an Azure dashboard and also in Power BI later on. All right?
Sounds good.
So I'm just going to minimize this one. And
yeah, sounds good. Go for it.
I believe you can still see my screen.
Yes, I am sharing your screen.
Okay. So when I am in Azure, I can look at all of my services that I've favorited, or I can search it through the top search bar up here. And there's a service called Monitor. And this is the basic foundation of all of this. Even from the overview page, we can go into monitor and visualize metrics, query and analyze logs, and set up alerts and actions. And those are the three main parts that we will also discuss during this session. And we will just briefly dig into the monitoring and visualizing metrics right away, so that you can see how fairly easy it is to get started. Obviously, we need services running in order to dig into their logs. And we've got a few running. And to enable this, let's just look at a SQL Server. Let's just pick this one. This is our production setup. You can see down here where the menu normally says monitoring, diagnostics, and so on. It just says logs for this SQL Server. So what's going on here? I thought that all of the services had diagnostics settings that you could enable and disable. Actually, with the SQL Server, it's either on a database level or if you have an elastic pool. The SQL Server is sort of a meta instance in Azure, so you don't get a completely full VM on your own. You share the resources, and that's why you have to go a level below. So if we look at a specific database, we can go in and see that the monitoring section actually looks like we expected it to. So I can actually go in on each instance and set up diagnostics on that service, in this case the SQL Server, or I could go in and set it up on the elastic pool. So we've created an elastic pool for the production databases that we run, and if I do so, I will automatically get pool-wise loggings as well. I could dig into metrics already and just start clicking in. SQL Elastic Pool Standard Metrics is the metric namespace. And then I can dig into, the different kinds of metrics that they expose. So CPU used is some of the obvious ones where you can actually zoom in. I just highlight an area that I want to enhance, and I can then enhance it even further. And I can also apply splitting. So the database ARM resource ID, and now it's all messed up until I select a different chart type. And now I can see which of the databases are actually consuming CPU used. So in under 5 minutes, I've actually been able to dig into some of the more analytic side of our metrics in the SQL Server department of our application. And that's pretty awesome, I should say. This goes obviously for almost all of the services in Azure. Virtual machines have them as well. We can go in, see monitoring, diagnostic settings. We can set up logs and so on. So given any service within Azure, you can have a number of ways to actually get the data out and store it somewhere else where you can query it later on, or maybe set up alerts and so on. So let's get back to the monitor part. And the visualize and the monitor part of that is actually all about creating visualizations on top of metrics, or only metrics. So now that I'm back in the Azure monitoring part, I can select, let's say we have a log and application insights running on this. So just selecting my application insights resource, which is in that subscription, and I can have different events and metrics that is monitored on that. It's called instrumentation key when you set up an application insight. So you can log from different services into an application insights instrumentation key, so to speak. So let's see, I'm not sure many of these are actually live, but let's check this one, incoming source data. So this is the blob storage where all of our production data comes in. And we can see that between 2 p.m. and 6 p.m. we had a surge in files coming in. And obviously, this is a quick way to actually, identify issues. If you want to go look for anomalies, and if you want to track back, we had an issue, what was it? Then go in and analyze all of the data. But the nice thing about these visualization is that you can actually pin it to a dashboard up here. There's an option up in the top right corner where you can change the charting type, obviously. You can create a new alert rule, and you can also pin it to a dashboard. So let's just try and pin this one to a dashboard. So I can pin it to an existing dashboard. I can create a new. I can have it be private or shared between others who are able to log into the Azure portal. So let's just keep this one for me, and this would be the Azure Community Live dashboard. And then I'm clicking Create and Pin, and it says Pin to Dashboard. So if I follow this link, I will go to the dashboard that I just created. This is also available from this menu item. So if I hit the burger up here, I will get a nice link to the dashboards, and I can select which one that I want. Or I could choose between the different dashboards that I've created. And this is a private dashboard, and these ones are shared. So I made an analysis with this query that I've zoomed in, and I did a lot of other stuff. So let's just imagine that we could set auto refresh on, and we can. So I can have this dashboard refresh the query that is lying underneath this visualization. I can have it every 5 minutes and up to every day. And all at once, it becomes all the more powerful because I can then just go into this dashboard and monitor some of my critical services. I can move it around. I can save it. So now I have room for more visualizations. Just go back into Monitor, create a new one. And that could be from, let's have another analytics application insights workspace. Like this, and see what. So let's see, we have this timely as processing. So this is where we are processing our analysis services instances. And I can add this pin to actually the same dashboard. So existing, private, and I can select which one that I want. And it also selects the most recent selected one. And I can just pin that into there. So again, I follow this link up here in the notification bar, and I'm back where I can then juggle around where I want it to be, like this, and save it. So now I'm monitoring 2 different application insights log directories, so to speak. That's pretty awesome. Now you see that each one of these visualization has a little funnel up here. And that's because you can actually set the time range for each individual visualization in here. So you can have it override the dashboard time settings. So the time settings that I had up here, auto refresh every hour and for the past 24 hours. Or I can have it adhere to the general settings up here. And when I hit apply, it will automatically update to the last range that is available for this visualization. So now it's live once I click save. And now I'm the only one to see it because it's a private dashboard, but still it's live and it's updating every hour. So I can go in and look to see if anything's out of the ordinary. All right, so that's the element of monitoring in Azure. What if I wanted to have an alert set up? So let's go back to the monitor part and explore some metrics. And let's select the DevOps prod again. And again, I'm selecting, so this is actually an Azure function that is logging into this application inside instrumentation key. And this Azure function is reading off a queue on a storage account. And once it's executing, it logs that into application insights. So I can actually have the count of executions by minute. And that's what we are seeing here. So let's see if we have more than 2 executions per minute, we would like an alert to kick off. And I can see that I have a couple of those. And if I want that to be notified to anyone, I can create a new alert rule. And with this alert rule, it's a bit tricky actually to set it up correctly, because in just a second you will be presented with some choices and options where you might not fully understand the consequences of your choices. At least we've had to redesign some of the alerts that we set up in order to have them alert on the right types of events. So obviously, this is also something that is costing you money if you set an alert up, but it's very, very cheap in comparison to what else is in Azure. But first off, you select the scope, and we were using the resource DevOps prop, which is the application insight service, and we've selected that as the scope for this alert. And now we need to select a condition. So configure when the alert rule should trigger by selecting a signal and defining its logic. And defining its logic is probably the more complicated part of it. So as you can see, we have a number of log queries saved. So files loaded last 7 days, last 14 days, sales loading progress, and so on. So we could actually tap into a KQL query that we already had stored within Application Insights, or we can tap into some metrics. So let's have a look at the timed AS processing count, which was the one that we saw before. Up here, the select time series is aggregate only for this type of event. And we can select how long a time range do we want to monitor. And now to the fun part, because you can actually split the result by any dimension that your logging might entail. So if you have a various number of dimensions logged with your data and your metric, you can actually have it specified here. Excuse me. But the alert logic is the one that is the most interesting part. And as you can see, Azure is already warning us up here. So about spending money. But it's not going to be something you notice on the bill unless you use this extensively. But the threshold for the alert can be either static or dynamic. And if it's dynamic, you have to choose some different scope. We will stick with static for this example, and you can read all about dynamic thresholds on an external link, and you can see the link right up here. But if we just choose static and we want to say that if we trigger more than 2 times per minute, we would like an alert. So greater than, maximum, and 2. And you might have noticed when I punched in 2 here, the black bar actually moved up here. So now it's reciting, oops, sorry. Now it's reciting at 2. So this is actually a visual indication of our limitation, or the limit, or the threshold down here. And the condition preview is also spelled out whenever the maximum timed AS processing count is greater than 2. And then you need to select how often is this evaluated and what range of time is it evaluated over. And obviously the 2 of those have, they come in pairs, so to speak, so you can't evaluate more often, excuse me, than your range. So if I say 1 minute, the aggregation granularity to 1 minute, it says evaluation frequency should be less than or equal to the search period. So I have to set this to 1 minute as well. So every minute it spans back 1 minute and says, is the threshold value bigger than 2? Then I want to have an alert triggered. I can hit done, and it says estimated monthly cost is 10 cents. So it's doable and not too threatening a number in terms of Azure, I should say. Next up, we would select actions, and this is where you define who is notified or how do you, propagate the alert to the right contacts. You can create an action group, and we've created a number of groups already. And if we just create a new group, and we want it to be in the Catman test resource group, and we want it to be the ACL demo. Oh, notifications, we want to select that. So we can actually have email Azure Resource Manager role or email text push voice. So we have this one, have text, etc. And we can then choose which email should be notified on this alert. I can also select a text message that is notified, or Azure app push notifications. So in the Azure app also supports these notifications. I'll not go through with this one. I'll just leave you with the example that this is how it's done. And jump out of this one. And so when you have the action group that you want, you select this one, and you can have multiple. And then finally, you specify the name of the rule. And this is where you can't change this after you've created the rule. So you should avoid punching in numbers like timed AS processing greater than 2, because if you change the logic to greater than 3, you can't change the title, and this can be confusing to the recipients of the alert. Also, you select the severity of the alert if you want to use that later on downstream. And you can enable on creation. And I can't create the rule because I need an action group specified. I think that's just a quick test. No, I can create it without an action group. So this can actually just trigger for me to monitor, and I can go in and have a look to see how many times it's triggered over a course of time, and then perhaps add a resource and an alert group when I'm happy with my logic in the alert. The one thing that you should know about alerts is that it sends out two messages, one when the alert is triggered, and then one when the alert is then resolved, so to speak. So if you have an alert rule that says when this threshold is exceeded, you should send out an alert. Then when you go below that threshold, it sends out an alert again, sort of to close it off and say, okay, we are below threshold again. You can breathe easy now. It's just if you have any automation picking up on the alert emails and Power Automate or something like that, we have a ticket system, Zendesk, where we pick up some of the alerts. And it's a bit annoying that we have to go in and close the extra ticket that is, and so on. So that's an annoyance, and you can't really configure that within the alert. All right, I think that's enough about monitoring, visualizing, and we also went a little into alerts and actions. Now we want to go into the KQL business of this service. I've opened up two tabs up here, and this is where I open up my one application insights service. And within that, I can go into monitoring and select logs. When I select logs, I will be presented with some ordinary queries that, response time trend that is typical for maybe virtual machines, alerts, and performance of different services and so on. And I can quickly, turn that off if I want. I don't want to see that every time I log in. And there's also a link in here to the community Git repo. And I've opened that up already. And as you can see, there's a folder called Azure Services, and there's a lot of them in here. And just like, let us take Cosmos DB. Within Cosmos DB, there are a number of queries for diagnostics. As you can see, so top logical partition keys by storage is one KQL query that is in there. And this actually can get you, a step ahead and have some code running before you maybe fully understand KQL. So that's just the main entry page. You can shut that off. And then you get the query window, so to speak. So as you can see below here, these are sort of the databases that we have available to us within this application insight service. So depending on which services actually, report into this specific key or application insight, databases will appear in here. We use custom events for some of our applications, and thus there is a custom events database. Also, performance counters, exceptions, and so on are the ones that are usually available to you. But as you saw before with the Cosmos DB, let's go back to this one. Diagnostics, top logical partition keys. The database is actually specified here, Azure Diagnostics. And that's one we don't have in the current application insight. So depending on which applications report into your application insight, you will have a different number of databases, so to speak, available to you. So the easy way to get going is just to double-click one of the databases, and let's see if we have any exceptions within the last 24 hours with that it has been reported to this application insight. And yes, there are plenty. We can see that there are 168 records. And we get some stats about the data that is returned to us, if we want to use that for any purpose. But we can also dig into each of the rows, so to speak, and see what the exception was about. So in most of the records that you get, it's pretty straightforward. So timestamp is an attribute to the data. It's just the JSON format. And you can also add custom dimensions and custom objects to your output into application insights, and that's displayed as this custom dimension. So again, JSON, we can see that a function timeout has occurred, host is shutting down. Okay, that's good to know. We want the details, and we can dig in to this and see, okay, so it was a value product info merger, which I know is something that is automatically querying a REST API for us, and apparently it's timed out, and we need to look into that. So actually, I only had to double-click exceptions. Now just double-click traces, and you can see it's already helping me define my query further, but I can just look at traces. There's one here, blob trigger function process, blah, 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 blah. And there's an Azure function that is triggered. And I can dig into that. So I can see, okay, so how many times has this been running for the last 24 hours? Or I just want the ones about the blob to be displayed. So now I just type in a pipe, and you might know this from PowerShell, just a pipe, which is on a Danish keyboard is located right next to the backspace button. I'm not familiar with other types of keyboard layouts, so I'll stick with the one that I know. And then I'm presented with a number of options to further distinguish my query. Now, we wanted to show only the blob trigger function processed blob thingy down here. And so I say where, and I can see that the attribute is message. So I type in message. And I actually only wanted to start with this passage because I'm not entirely sure that the message is identical, as we can see up here. This one is obviously a data dump from Finland, and this is a data dump from Norway, and this is a data dump from Denmark. So they differ, and I just want to compare with the start of the string. So that's last 24 hours. We should see 4, Denmark, Norway, Finland, Sweden, and these are files that we receive once a week, which is processed as such. So that's fairly easy to have going. So I can, usually I want to format my query like this, so that I can even say multiple where clauses, message, then ends with, and then we want So now I've had two where clauses in the same statement, which is maybe silly, but it's just to let you know that that's actually possible. Now that could come in handy on a later stage, where you have a number of objects that you need to expand and so on, and then have it filtered again. And we will see an example of that shortly. So we could also say count message. Should have prepared this one. All right, let's have a look at another query that I actually prepared for this. I was just getting eager to get going. So the where clause that we just saw, I've had a number of queries prepared out here, so that when I'm happy with a query, I can have it saved. And when I do save a query, I can give it a name. I can have it save as a query, and we can see the other option in a minute. And then I can save it to my queries or shared queries. So shared queries will be shared among others who has access to these application inside logs. I can also share it as a function. That gives you different options. We will be solely focusing on the queries in this session. So I've saved up these queries beforehand, so we could get to them easily in this session. And I've already showed you the where clause, and now I'm running a query that we saw earlier on. So the tabular database is processed, and that event is called a custom event, and it has a name. So how do I know what attributes are available to me before I even query? If I expand the custom events database over here, I can actually browse the different types of attributes that are in here, and I can see timestamp is a date time, name, string, and so on. And then you get these dynamic data types, and those are to be treated as JSON. And KQL has various number of functions built in to actually deal with this. So that's also a way to get help in here. The query language actually is built for this. So this is the ordinary kind of where clause where we filter, and we can also order by, and you see we get some kind of intelligence in the tool already. And the one key you don't want to hit is F5, because then the whole browser refreshes. And if you go from a SQL background, as I did, I hit F5 all the time, and I end up, refreshing my browser, and the query is lost. But otherwise, you get intelligence within this field where you define your query, and you can have a look at the attributes over here. So, and you can also see examples of them down here. And you can also say column actions, you can exclude or include. And you can exclude or include. So if I only want to see this CM next bat NL, I can see that it adds another where clause to my query, and it kind of dots its way through custom dimensions into database, and then has the equal sign, comparison sign, CM next bat NL. So let's see. Oh, we have an unfinished order bar here. Like this. So the Dutch BAT solution has been processed 2 times over the last 24 hours. is what this query tells us. So you can also use the easy way to get going, just to run the custom events. I want to see this one. I want to see, yeah, it's the BAT&L again. Let's take another one. How about ALA? And it's been processed 3 times. So you can see, even though I'm not familiar with the KQL language all up front, I can make my way around and query stuff at a basic level, at least. So what do I do about all of these columns? I don't care about the app ID, the cloud role instance, and so on. I can actually tell what I want to have displayed to me, and when the query returns its result set. And I do so with this statement, project up here. Oops, sorry. This one, where I actually tell the query engine that I only want timestamp, name, and value to be returned to me. Now I'm querying the income source data custom metrics. So I see the number of files in store at any given time of the data. I could also say the other way around. I want to project away, like this statement. I'm actually selecting, which columns I don't want to see. So client browser, client city, client country region, and client IP. I don't want to see those. I want to see everything else. So now we see a lot of other stuff, but we don't see client browser, client city, and the ones that I specify in this statement. All right. So what if I wanted kind of bucketed in? So I have some performance counters, and I want to see the top 10 of something by instance name or by service name. I could do that by this option, partition by, and I then partition by the name and say I want the top 10 by value of each name. This actually, if I just run this performance counters, we'll just see the entire list over the last 24 hours and see performance counters for, let's see what we have here. So this is some functions, Azure functions that are running. And then I can add partition by name, top 10 by value. And I see the requests in application queue 10 times, request execution time 10 times, number of exception throws per second 10 times, request second 10 times, and so on. And then I can finally order that by name. So this also gives me an option to, group my data into different categories to see the difference between 2 services, which one is worse or better, and so on. So that's partition by. When we look at these data sets, we have these custom dimensions. And what if I wanted this to be, expanded? I could actually do that. And it's not expanded, it's called extended or extend. And we get back to the classic tabular database processed. This is the event that we just saw before. And as we can see within that event, we have a custom dimensions in here, and we have duration in milliseconds. So this database took this amount of milliseconds to process, and I want that to be displayed as a regular, column in my result set. So I can do that by using the extend option, and then I name my column up here duration and equals it to a toString, custom dimensions, and duration milliseconds. I have to use this special quotations and brackets because it's a name with spaces in. So I have to enclose this this name in these different. It's known way of doing it in SQL and so on. But also I have to convert this into a string because this is, as we saw, a dynamic object or dynamic data type, as we can see here. So the KQL engine doesn't really know if this is a string or whatever it is. So in order to actually make something meaningful out of it, I convert it into a string, and then I project the timestamp and also convert this duration into a number. And then I can see, okay, so these are the number of seconds the different databases took. So I can extend that actually even further. I can say database equals string custom dimensions of database. And then database, and you see all of a sudden database, I defined that up here, and it's already available to me in code completion down here in the next line. That's pretty awesome. You also notice that this is a different icon than the others, so you know that it's something that I constructed within the query. But as I write database here, I can run the query again, and now I can actually identify which database is the one that is actually taking how much time and so on. So that's a way of actually extending JSON structure within the records into actually something that you can report on top of. Now, this is the natural jump into, we want to see the visualization on top of this, and this render query is just an extension to that. You can see here that it's almost the same query. We don't have database with us anymore, but instead we have this render column chart. And when I select this render column chart, I have a number of options. Area, bar, column, pie. You don't want to use pie. Scatter chart, table, and time chart. We had column chart selected for this one, and let's just run. Now you can see it's fairly tiny, and we might want to, narrow down the scope. So I can add a where clause to this one, and timestamp. Still available to me because I projected it into the data set. And I can say that my timestamp should be greater or equal to, and then I have this option, which is quite nice for KQL, ago. And in this function, I can actually add a number of different time spans. So there is a short notation for 1 day, which is 1D. So a single day, I could also say 1 hour, or I could have it 1 minute. Nope. no results found. So we could have 10 minutes maybe. There you go. So this is something that is really, really nice. The way that KQL handles, periods and time in here is really nifty. This moves me on to the next query, which is between, because actually this ago can be used in a number of ways. So back to the same old tabular database process, I can select a where clause where timestamp has to be between 5 days ago or 4 days ago. Or I could say 10 hours ago. I can mix and match the kind of time span that I add into the function, and the KQL doesn't matter. It's just eating it up and processing the results. So that's also a pretty nifty feature of KQL in here. Okay, so I can also aggregate, obviously, within KQL. So I want aggregations over time. We are now back to our custom metrics, incoming source data. So the number of files, we see that in the value option or attribute here. And I can then order by value descending. I want the biggest number on top and descending numbers in falling order. And then I want to summarize the average value by buckets of 30 minutes. So now my query is returning 30 minutes buckets and the average value in those 30 minutes. So between 10 and 10:30, the average value was 9, and so on. It's still respecting my value order, which is pretty awesome. No, it's actually not. And in order to do that, I would have to name this one and then order by. There we go. So I can see the busiest half hours of the day where we receive most of our files. And that's different for each day. So 4 p.m. in the afternoon on the 15th, and 10:30 on the 16th, and so on. So there's a variation. I could also render that as a chart. So we see the not so thin spikes as we saw before, but more, compelling column chart. All right, so this was enough of the basics, and I believe I'm not sure how much time we have, but I wanted to show you one more thing where we actually join different data sets. I don't know, Lars, if we have time for that.
Yeah, go for it. That's fine.
Okay, good. So I'm moving into another Application Insights log registry. You can click that away. I've saved a query over here where we are looking at the weekly processing of files for each of our clients. So we receive files for all of these clients, and then we do some KQL logic and querying to the data in order for us to assess, did we receive this week what we were expecting? Each week, all of our clients sends in a number of files that they receive from retail, department stores, supermarkets, gas stations, and so on. And they come in roughly the same number of files every week. So this is a fairly good estimate of how much of this week's load is complete. But to do that, we have an issue with the fact that we are actually only logging this solution ID into our application insights log. And this means that we are only logging the ID of the solution that we are crunching the data for. And we have to some way convert that into a meaningful and displayable kind of name into the reports. So I've created a data table in this query, and we call that solutions. And we define that as a data table with these columns. I then immediately start to add rows to that data table. So I have a solution ID, which is an integer, and a solution name, which is a string. And then I just list up the different clients that we have in here and round it off with the short parenthesis and a semicolon. Then I have a number of timekeeping variables: weekday, end of last week, and start of last week. Those are some time math that we need later on in the queries, because we want to compare the complete week of last week with the current week, sorry. And then obviously we query into our custom events. And if I just select this up here, I can actually run this, and they're getting me back data. And this is more than 30,000 results and so on. We should narrow down the set, and we do that. So the first query that we want to have on one side of the join is the custom events where timestamp is greater than or equal to start of last week, and well, in between start of last week and end of last week. And let's see how many events that will give us. Still 30,000. So, and now this is just to show you two options of doing JSON. We can excuse me, we can use the built-in parse.json function on custom dimensions. So as you can see down in the attribute set here, we have this custom dimensions, which is a number of attributes and values. And we can actually have that passed into another column JSON. So we can have this as a short notation. And it's actually just the same as if we just used custom dimensions dot job execution ID or JSON. That's just to show that the function is there. We then extend all of the attributes within the JSON into proper columns, and we project them into the final data set. So the one thing that we actually do in here is, well, we convert this to an integer because we have to compare it to the table up in the top. And then we have a built-in function with the week of year within KQL that is some time intelligence in there. So let's just have a look at this query, what that returns. So we will get a solution ID. Some of the events in here don't have a solution ID because it's something that is not, relevant or triggered by a specific solution. A channel item is mail, FTP, kind of a different source we have. And then the function, you can see FTP, mail reader, and so on. We get a timestamp, message, process, and week. Okay, so we want to know that data is loaded from a certain file. So we just add that to our where clause, and we should, the next where clause there. So we won't have any file empty. So we want only rows where data loaded from and then something is present in the message. So now there's a pattern emerging in here. So we can see these are the files: Tulip, Unilever, BKI, BMS, specification, and so on. So 600 pages, scoring area, and so on. So we see a lot of data coming in. And then we actually just want to summarize that by count of file by week and solution ID. So now we end up with a very narrow row set. So one with the week and one with solution ID and files. So these are the number of files we received from solution ID 11 in week 9. And then we kind of average that off at the end, just to see that over the last or the previous 4 weeks, the weekly average was this. So you can see the time intelligence up here is actually 28 days. That we're spending 4 weeks in this query, and thus taking the average over 4 weeks to compare with this current week. So we almost do the same query down here, where we add the join to what we had as output up here, and then we join an almost similar query down here, and we summarize also by solution ID, and then the magic part is maybe missing like this. So we have a join, custom events on, custom events again, and we want to join left solution ID to right solution ID. So we want to join the solution IDs on both sides. And finally, we project away solution ID 1, extend %done, which is a comparison of the two measures that we calculate in each table. And we then project solution and %done at the end. And let's have a look at the complete query. Now, like this may not look all that fancy, but if we look at the chart type for this, I should be able to look at the, I would have a line chart like this. This is what we have at the dashboard. So we can see that the 100% is the normal, and we see that Unilever Sweden is only 0.5% done. And some of this lag that we have this week might be due to the course of Active Directory breakdown on Azure last night. I don't know. But usually we're better off at this point in time of the week with our data. But yeah, so we can track and see who is actually going towards the 100% done, and see who we need to maybe check up on and get some data from. All right. So this was a more advanced KQL with a join. And if I wanted that to be exported into Power BI, say, I have an option up here with the, and then it gets a bit cryptic maybe, because you can export it CSV all columns and displayed columns, or you can export it to a Power BI M query. And the way to get it into Power BI is actually pretty easy. So when I open up the file, it says, a query almost identical to the one that we just saw with some metadata surrounding it. When I open up Power BI desktop, I just need to go in, and the guide is also in the query already. So if I look at how to get it. I need to download the Power BI desktop. I need to go into Power BI desktop and select Get Data, blank query, and go into the advanced editor. So Get Data, blank query is down here, this one. And then when I have the blank query open, I can then select the advanced editor up here. And once I do, I'm prompted with a text field, and I can just copy and paste the mQuery in here. And obviously this is not, maybe I missed it. Let's see. No. Bad request. So maybe this is due to AD. I just tested it before. Let's see if, no. Okay, so this is the way to do it. Apparently I'm also not being prompted to to actually authenticate, which would be the first step. So I would actually need to authenticate into actually being allowed to fire off this query. And yeah, okay, so if this is the glitch in my demo, then I'm okay with that. But this is actually the steps, and then you can add, you get the data set in here, and you can add the fields in. And with Power BI, you get an option to actually update that 8 times a day if you want. And you can have that in your nice Power BI reports in your tenant. Also, as we saw before with the alerts, we can create alerts on queries. And this has a different estimate, and you can see that up front, so you won't get any surprises. But you still need to define the logic in here. And some of the KQL is maybe too advanced for the query logic, or maybe there's an issue with, with Azure still. I don't know. But yeah, then again, when you've done your query, you can set up alerts on top of that, and that should keep you safe and notified once you have it configured. All right, to get started with this, go have a look at the Azure Community on GitHub. There's a number of resources there. And also, I know there's a course on Pluralsight, which is free. And just let me check for KQL. By Robert Kane. This Kusto Query Language from scratch, which is really good. It used to be free. I'm not sure it is now. But this is actually a very good resource as well. And he goes even deeper than I did in this session. That's pretty much what I had to present on KQL and monitoring in Azure for this session. I don't know, Lars, if there were any questions or you have questions.
No, I did have one question, to be honest. So you answered one of them that I had, was sort of like, where's the best place to start? But you just showed us the GitHub kind of pages and the Pluralsight course. I'm just wondering, because I'm sitting here looking at it with my developer glasses on, and I'm wondering is there some way that we can use this through an API? Do I have to go into Azure every time I want to use KQL?
No, there is actually an API you can hook into. I haven't prepared any
that's okay.
details on it, but you can create an API key within the application Insights service itself, and then you can hook up to it. So and the REST API for this is fairly well described, I believe.
Okay.
So
yeah,
you
it's
can,
just I could see that becoming really handy because
Yes.
it's crazy powerful. Like I've used it maybe twice, 3 times, and I've
Mhm.
put on sort of like, oh, how much SQL do I know? How do I convert that into KQL? And I've just sort of got lost.
Yeah.
But yeah, it's there's a lot you can do.
Yes, there is. And actually the query editor in here is actually getting better and better. You get some, there are some examples that you can, base your queries out of, but also from the result sets, you can just, the basic stuff you can do already, and it's getting better and better by the time. So
Yeah, it's all written in JavaScript. It's quite impressive.
yeah, it is.
So that's awesome. I didn't have any other questions because I thought it was really, really well explained, if I'm honest. I followed it very easily. So I think this is one of those reference talks almost, like if you want to start out, hey, start here, because it's sort of like gave you the whole journey. So that's really cool. So thank you very much.
Good. Yeah, thank you for having me.
And as always, if you want to give a talk, just like Jens did, get in touch. We're always looking for speakers to try and fill up this sort of virtual space that we have, and hopefully we'll see you in the future at another one of these talks. And as always, check out all the other talks on our YouTube channel. This is number 27, as far as I remember. So we're getting to quite a good catalog, and there's all sorts, all different types of presenters, all different types of topics. Everything is here. So hopefully we'll see you with that. But other than that, thank you very much, Jens, for your time.
Yeah, thank you.
This morning for you, this evening for me, and see you everybody next time as well. So
see you
later.
Bye-bye.
All right, and that should have ended that stream.